Hello, everyone. Welcome to this lecture of computer system security. Today, we are going to talk about intrusion detection systems. We're going to finish that kind of topic, and also we are going to open a new discussion, the second part of this lecture, which is about firewalls. And then in the next video, which is basically the last video that you are supposed to prepare for the exam, we're going to talk about intrusion prevention systems. Okay. If you remember, this is a point that we kind of left the previous recording, and this is the last part of the intrusion detection systems. We are going to talk about honeypots. What are the honeypots? Honeypots basically are kind of fake or decoy systems that we put in our network in our organization in order to attract the potential attackers to them. So we basically want to fool the potential attackers and want to keep them away from the critical assets of our system. Honeypots also can be used to collect information about the attackers and their activities. And of course, they encourage the attacker to stay on the kind of fake system for a longer time. And this gives the administrators of the system to kind of prepare for response or to patch the vulnerability. And that way we kind of keep the main or the genuine assets of our system safe and kind of protected. And basically, these are systems which are filled with fabricated or synthetic information, which have the same appearance or same kind of format of the legit information or data that we may have in our system. So in terms of appearance, they're very similar to the legit and genuine information, but no legit user is allowed to access them or is allowed to work with them. Or basically, they are not proposed to the legit users. So since the normal users or legit users are not supposed to work with these data or are not supposed to work with these assets, this means that any type of incoming communication toward these assets, that might be a transaction or a communication coming from an attacker. So initiated outbound communication suggests that, okay, system now probably is compromised and something should be done. This figure shows how a kind of honeypot works. We have our network here. We may have some kind of local switches or firewall. We'll also talk about firewall today. And these are all kind of our authentic users that they're supposed to hear to sit and work. And we have a honeypot here, basically. If you see no user is supposed to work with the honeypot, or we have another honeypot here. Again, this is a honeypot. None of our servers, these might be the servers and these are the kind of workstation. None of the users are supposed to work with this honeypot. There is no information here. But if any kind of inbound communication comes toward this honeypot server, it means that the system now is being attacked and the system is compromised. So yeah. Okay, we can implement the honeypots in two different kind of ways, or two different approaches can be taken in order to really develop honeypot systems. One is called low interaction honeypots. A low interaction honeypot basically consists of a software package that can be installed or can be run on any of actual servers that we have, and it mimics or emulates a realistic server, a realistic asset in our network. And when when attacker tries to kind of communicate or interact with that low interaction honeypot or with that software package, the um, the package kind of initiate the communication mm, with that person or with that individual. But of course, it doesn't provide a full set of services. It just shows or mimics the initial communication between the server, alleged server, and someone that tries to attack that server. So the person kind of will be treated in a way that the server is going to start the communication, and that's it. Just a very few steps of the interaction or communication between the between an actual server and the user is being mimicked, is being kind of followed by a low interaction honeypot. The good thing about low interaction honeypots is that it's kind of very easy and cost effective to develop them, because what we need is basically a software package that we install on a real server. And of course, that works for some given ports or for some given communication. Not all communications are going to be redirected to that software package, but that software package takes care of some of them. And the reason we say it's kind of cost effective or cost efficient is that you don't need to put dedicated hardware systems for them. What we need is basically a set of applications or software that we install. But the downside is, since it doesn't provide a realistic communication all the way until the actual communication is being done between the server and the user or the attacker. Attacker may know at some points that, okay, here is not an actual server. This is a honeypot server that tries to kind of catch me. So attacker may kind of leave and may go. It may keep the attacker busy for a while, but that time duration is not too high. It is often sufficient for some cases. Of course, one good example is the cases that we have distributed intrusion detection system. It means that we have other layers of security, and here we just put some low interaction honeypot for kind of improving or boosting our security. In contrast, we may go and we may kind of pick high interaction honeypots. High interaction honeypots, they're actually real systems, real servers with a full operating system, full stack of services, and all services applications are being kind of run on them, are being offered by these high interaction honeypots, and they are instrumented and deployed somewhere that can be accessed by the attacker. And of course, they kind of offer a very realistic experience to the attacker. So if attacker tries to compromise them, there is no way for attacker to realize that this is not a system that's worth to attack. The only time that attacker understand, okay, this was a honeypot, is once the attacker compromise that server, compromise the honeypot server, and collects the information and checks the information. For example, a honeypot may have some fake username and social security numbers. The only time that the attacker understands that, okay, it was a honeypot is once they compromise the system, they collect the information, they check some of the social security numbers, and they realize that, okay, these are not valid SSNs. These are just some fake SSNs in some fake database. That's the only time. So here in kind of high interaction honeypots, we can keep the attacker busy for a longer period of time. And of course, this comes at the cost of having a real system dedicated to kind of to host the honeypots system and application. Okay, this is what I wanted to mention for the kind of completing the intrusion detection systems topic. Now I'm going to open the second part of this lecture, and I'm going to talk about firewalls. In the next video, I'll be talking about intrusion prevention system, and these conclude the lecture 5 of this course, which is basically the last lecture you are supposed to study for the exam. Okay, let's talk about firewalls. First of all, why do we need firewalls and what are firewalls? Um, we know that internet connectivity is now a must for almost all organizations. And if as an organization you don't offer internet connectivity, you may end up having your users using their own cellular or Wi-Fi network, which is even worse because you don't have any control over them. So if you want to control and kind of regulate some policies, some security policies, it is better to have your own uh, internet connection, have your own kind of network support to provided to your users, and then you can of course apply your security regulations and policies. However, we know that the outside world, it can be bring anything to your network organization, to your uh, workstations, and to your basically to your security assets. So firewalls, and this is also kind of an alternative way with respect to firewalls. You may argue, you may say that, okay, I try to equip each of my workstations, I try to keep them secure enough, and so that probably I don't need any firewall. This might be not sufficient in all situations, and for sure it's going to be very costly for you. If you have, for example, an organization with, let's say, 200 workstations, 200 users, and you want to make all of them secure enough, it might be, first of all, not efficient because you may end up having different systems with different operating systems with different hardware features and different processing capabilities. So it's not easy to keep all of them at the same level of security. So it's going to be very difficult and sometimes inefficient. And at the same time, it's of course going to be costly. So that's why the idea of firewalls kind of come on the table. A firewall is basically an application that kind of is being inserted between the local network or the premise network and the internet. And the idea is to control the link, control the information which is being transmitted between the internal users or internal network and an external network. And the firewall is supposed to kind of to offer to provide a control link for the users of our organization. And of course, a firewall can be a single computer or can be a set of computers that work together and they do the firewall for us. It used to kind of work as a perimeter defense because, of course, it's making it's a defense mechanism that surround your network, and of course, we can see it as a one example that supports the idea of defense in depth. You remember in the very first lecture of the course, one of the security concepts that or principles that we talked about was layered defense. And firewall is one example of defense in depth or layered defense. Okay. Now let's talk about the design goals for firewalls. The goals that we kind of try to achieve while developing or incorporating a firewall into our system is to, we want to, of course, all traffic which is being transferred out of our local network and also is being forwarded toward our network is being controlled. So we want all traffic inside and outside bound to be controlled. And this happens through the fact that all of this traffic should pass through the firewall. And of course, only authorized traffic, which are defined based on some security policies, will be allowed to pass, and the rest of the traffic will be refused, will be rejected. And that's why we believe that having firewall helps improving the security of our system, of our organization. And very last thing about the goals of having a firewall in an organization is that the firewall itself should be immune from any type of penetration or from any type of security attack. Because of course, the moment you say that my system has firewall, the firewall is the first thing that attackers try to attack to. So it should be hardened and it should be secured enough. So it means that it's going to be costly developing a firewall, and it's going to be costly to run a firewall. Okay, I've talked about, I just mentioned to the security policies. I said that there are some security policies in a precise term, they call it access policy. A firewall access policy is actually a set of policies that they specify which type of traffic are authorized, which type of traffic should pass through the firewall, and which types of traffic should be rejected or denied. Of course, the access policy, which is being implemented on the firewall system, it looks at multiple things. It may look at the address range. It may look at the type of protocol. It may look at the application, and even it may look at the content of the information which is being kind of passed through the firewall. And based on some or all of this information, the access policy kind of determines if the packet, if the information should pass through the firewall or it should be rejected or denied. And of course, we know that such policies should be developed in compliance with the organization security requirement, and which basically kind of comes from a risk assessment process. You do a risk assessment in your organization. After you do risk assessment, you develop your high-level security policies, and those high-level security policies help you to develop and define firewall access policies. After we do such thing, a broad specification of kind of type of traffic that we want to accept or reject is going to be determined, and then later we refine it to some details and implement some type of filters inside our firewall. We'll be talking about the filters and type of filters that can be implemented in a firewall. Basically, firewalls can be categorized or are being categorized basically based on the filters that they have. And like I said, these filters are detailed implementations of the access policy of the firewall, which comes from the security policies that you have in your organization. Okay. So now let's ask this question and answer this question, that what might be the characteristics or parameters that someone may use in access policy of a firewall. According to NIST CSP 841, there are a couple of these standard kind of listed a couple of characteristics or parameters that can be used in firewall access policies in order to filter traffic. That includes, first thing is IP address and protocol values. These are kind of determined information which are being used for routing, for transforming, for forwarding information in the IP packets in the TCP IP network. And they are these are very low level kind of fields of information. So this type of filtering, if filtering is being done based on IP address and protocol values, this is kind of that type of firewalls. They are called packet filtering firewalls, and also stateful inspection firewalls. And technically, they used to limit access to specific services. But other than IP address and protocol values, we may look at the, or a firewall may look at the application protocols and implements the filtering based on application protocols. For example, you may want to transfer some information following the SMTP protocol, which is a protocol for kind of transferring emails. And of course, when it comes to that SMTP protocol, you may want to inspect the information, look at the content of the information in order to find spams and reject spam information. So you see here, we are not talking about packets and IP address and stuff like that. We specify as certain protocol or certain application. And for that certain protocol or certain application, we are going to do some extra or higher level of filtering. Basically, application level protocols, they relay, monitor, and filter the exchange of information for some specific application protocols, like the example I mentioned, or for some HTTP. If the packet is an HTTP packet, a packet coming from the HTTP protocol, in that case, we may look at and browse, and reject some of the addresses that we know them, they are not legit addresses. For example, in some organizations, some addresses, some URLs are blocked. That's because, for example, you want to go some address that this may happen probably not in the US, but in many other countries, for example, other countries I know that they filter some, let's say, medias. And the way it happens is they look at the HTTP protocol, and when it comes to HTTP packets, they look at the URL and blocks or reject information or packets regarding that specific URL or that specific address. Okay, another type of parameters or characteristics that can be used for filtering in firewalls is user identity. In this type of filtering, basically, the user first needs to be logged in or needs to be authenticated through the firewall. And then based on the user identity, the firewall decides if the information, if the packets are the firewall receives should pass through or the packets should be rejected. And typically this is good once we have some insider or inside users, and we have the authentication policies in place, and we first kind of get them authenticated. And after the users are authenticated, we now rely or we now trust on them, and whatever packet they produce, we forward. But if the user is not authenticated, we don't forward those packets. The firewall doesn't forward those packets and just drop them or reject them. And lastly, the fourth group of characteristics or parameters can be used in implementing firewalls is called network activity. Many network level parameters can be used in the firewall in order to decide if the firewall wants to filter or wants to forward a packet or some packets. So the access control can be defined based on parameters, like, for example, time of request or rate of request. For example, if some services might be only available at a certain duration of time. For example, some services are only available in business hours. If it's out of the business hour, the firewall reject that information, reject that that packets, and the kind of the service is no longer available. Or at a certain rate of request. For example, you cannot access some servers, let's say 10 times a day or 100 times a day. You have a limited quota for requesting that service. So these are all examples of the cases that network activity parameters can be used in the access policy of a firewall. Okay, now let's talk about the uh, capabilities and limitations that we may have in firewalls. Capabilities of firewalls are these. They can define a single choke point, which means that there is a single point in the organizational connection to the internet that if that point decides, no traffic can go outside, no traffic can come inside. So this is a very good thing. It means that administrator would have a very kind of effective and strong control over the whole traffic that comes uh, out toward the internet or comes into the local network. Yeah, it also provides a location for monitoring security events, which is good. We can look at the security events that happen in our organizational system or organizational network. It's a convenient platform for several internet functions that are not securely related. So we may have, this is very kind of interesting feature of firewalls. We may have multiple services over internet. We have email, we have web browsing, we have file transfer protocol, and they're all different with different security requirements, with different security needs, and with different perhaps vulnerabilities and attacks. So if someone wants to address all of them at a time, it's going to end up having a multiple solutions or multiple patches that just sit together. But firewall gives us the option to address all of them at a single place. We can address security issues of different functionalities which are not security-wise related, but we address all of them at the same place. And it can serve as a platform for IP security, but the limitations of firewalls are these. It cannot protect against any type of attack that bypass or puts down the firewall itself, which means that if any attack comes and put and kind of attack the firewall itself, the firewall of course cannot work anymore. The firewalls are not good for protecting our local network or our organizational network against internal threats. Of course, that makes sense because it's all about the traffic that passes through the firewall, and it's not about the traffic that kind of circulates inside our internal network. Improperly secured wireless LAN can be accessed from outside of that organization. This is again something that we should look at it. Handheld devices like laptop, PDA, and portable storage devices might be infected outside of the organization and outside our local network, and they can be attached internally. So this is a very big concern. You have a firewall in ANT and everything is supposed to be protected, okay, but I have my computer also connected to my local network as well. I attach some disks to some flash disks to it somewhere sometimes, and my computer might be kind of compromised. There might be some, let's say, virus or worm or whatever, and I now come to ANT and I try to use ANT's network. So the ANT firewall cannot do anything at this situation because that type of kind of malware is being transferred physically, not through the firewall. Okay, let's talk about types of firewalls. Types of firewalls, basically, we have four or five different types of firewalls. And what kind of makes a difference between them or makes differentiation between them is the level of information that a firewall look at. A firewall may look at very low level network packets, and the firewall decides about if the firewall wants to pass the packets or reject them, or it At a slightly higher, a firewall may look at the traffic within the transport connection, or at very high level, the firewall may look at the application protocols. So we'll talk about these in details, and we see that packet inspecting firewalls versus transport connection inspecting firewalls versus application firewalls. We'll see all of them in details. Another thing that somehow categorizes firewalls is the way the filter works. Firewalls may be positive filter, which means that they allowing to pass only packets that meet a specific criteria, or negative filter. That means that they reject any packet that meets a certain criteria. So basically here we are searching for legit packets and let them pass. Here we are searching, here we are seeking for unlegit and, let's say, unauthorized packets, and we want to, the firewall wants to reject them. And like I said, depending on the type of firewall, the firewall may examine, may look at the one or more protocol header in each packet, the payload of the packet, and the pattern generated by a sequence of packets. Again, we'll see this in the kind of details that we'll talk about different types of firewalls. Okay, the first type of firewall that we want to talk about is called the packet filtering firewall. It basically applies some rules on each incoming and outgoing IP packet. When we say IP packet, it means that we are talking about the specific packets in the network transport layer. Of course, I don't want to talk about layers of the network, but IP packets are at the transport layer, and it typically follows a list of rules and tries to match them with the IP and TCP headers. It forward or discards the packet based on these rules. So, okay, what are the kind of parameters, or what are the characteristics that that the packet filtering firewall looks at them? Those parameters are listed here. It might be source IP address. What is the IP address? This is the IP address. Probably you have heard about IP address. It's a 32-bit digit that kind of specify the address for any node on internet. So a source computer, if you want to connect, for example, to google.com, your computer has an IP address. The google.com also has an IP address. So the source IP address is a parameter, is a characteristic that of course can be used by the packet filtering firewalls. Destination IP address is another IP address that which is being used by the packet filtering firewall in order to decide if the packet should pass through or if the packet should be discarded. Source and destination transport level addresses, TCP and UDP packets, they have something which is called port number, and that port number sometimes it defines the application. It says that, okay, is this, for example, email packet or web browsing packet or file transfer packet or anything like that, which is called port number. The port number itself is also a packet level information and can be used in order to give the firewall some idea, some clue if the packet should be forwarded or should be dropped. IP protocol field, these are all information that are being used by the packet filtering firewalls. And of course, again, they can be positive or negative filters. They can be, the default can be discard, prohibit unless something is permitted, and the default can be forward. It permits everything to go through, otherwise it kind of discard the traffic. Here is an example of a table of packet filtering firewall. You see here, it says, for example, this is an inbound traffic and source is external, destination address is internal, protocol is TCP, destination port number is this, 25, and the firewall has decided to permit this kind of packet, this flow of packets to be uh, to go through, to come from outside network to our internal network. The second line says, okay, this is, of course, this is an example. This table may kind of may go way longer than this, and sometimes if there is no packet or there is no traffic, the table kind of may be even empty. The second one says, for example, this is an outbound traffic, means that from internal IP address. So here there should be an IP address. When we say source address, here there is an IP address for the internal node. There is an IP address for the external server or node. The protocol is TCP, port is this, and firewall has decided to let this also go through, and so on. And this table, of course, is being, like I said, populated while at the runtime, some new users try to generate new packets. And the thing about the packet level filtering is that they look at every packet as a kind of separately. They look at every single packet separately. Mm, But what I mean is that they don't try to find, for example, a pattern between multiple packets that which is being transmitted between that specific source and that specific destination. No, they just look at the packets, and every packet is being kind of decided on its own. Okay. Okay. Let's talk about the advantages and disadvantages of packet filtering firewalls. A packet filtering firewall uh, has disadvantages. First of all, it's very simple to implement because you just need to look at some, you just need to develop some IP-based rules, and those rules are very easy to be implemented in the tables or in the access policy of the firewall. And their second advantage is that they're transparent from the user. And because of being transparent and because of that simplicity, they're very fast. But the weaknesses or shortcomings is that they cannot prevent attacks that employ application-specific vulnerabilities. So it means that if you have vulnerability regarding some application, for example, your HTTP protocol or your browser has some vulnerability, the packet filtering firewall cannot detect that because the packet filtering firewall doesn't look at that level. It just looks at the information of packets. It doesn't look at the application or protocol. They're limited in logging functionality because functionalities are not being watched or not being examined here. Like I said, again, they just look at the uh, packets that they're being transmitted toward and into the network. They don't support a user authentication because they don't care about who is generating this address. Is that person is authenticated or not? They just look at the IP address of the source and IP address of the destination. And basically, the user authentication information is not available at the level that the packet filtering firewalls work. They're vulnerable to any attacks that kind of attack TCP/IP protocol. If I can somehow change the port number or IP number of some packets, I somehow basically can bypass the packet filtering firewalls. Improper configuration in the policy table can kind of lead to breaches. And like I mentioned, for these items here, they don't look at the higher level information or high level context. They just look at the individual packets and they make the decision based on information of each packet separately. Okay, in order to bring some level of context into the decision-making process, we have stateful inspection firewalls that they look at the packets like packet filtering firewalls, but also they kind of look at the records of information about that TCP connection. So which means that if there is a connection between a server and a user, and there are multiple IP or TCP packets being transferred between these two, all of those are being treated as a whole. Which means that, for example, if you are connecting to a server, the first, second, third, and the last packet from the same user, sorry, same client and same server, they are being treated uh, the same way. For example, one example case is kind of the example I have here. They, for TCP packets, they tighten the rules by creating some directory for outbound TCP connection. What they do is they try to create an entry for each established connection. The established connection means that a server, a user has already connected to the server. This TCP connection is being established. So any packet that goes after that connection establishment, they're all being treated as packets of that connection. And they're all being kind of treated the same way. Uh, in this example, the way the firewall works, the firewall look at the port number of the traffic. If the port number is low, the information is kind of being transmitted without any problem, is being forwarded or is being toward the out server or toward the internal client with no problem. Why? Because here is the note: the low number ports, any port between 10 24 are the ports number which are kind of well-known ports, and they're permanently assigned to particular applications, like for example SMTP or HTTP or stuff like that. So if a packet comes from a port number smaller than 1024, it means that that packet is something known. So the firewall kind of treat them easier. But if the packet comes with a higher numbered port, that means that this is a user packet, and that packet should be kind of investigated more. Here, and the same thing here, it keeps track of the TCP IP with the sequence number and inspect data for the protocol. Here is an example. We see here the source address, destination address, and the source port, destination port. Here this connection is established, meaning that any other packets coming from the same address, same source address to the same destination address is being treated the same way, and that packet is being kind of forwarded, which basically means that we are looking at a sequence of packets, and of course that makes the decision making easier and faster. But of course, we need to sorry, keep this record of established connections. Okay. At a higher level, we have application level firewalls that sometimes they're called application level gateway. They're also called application proxy. And they have a kind of major difference with the two other types of firewalls we just talked about them: packet filtering and stateful firewalls. Stateful firewalls and packet filtering firewalls, the way they work is the firewall is here. Let me go back to this figure. I need it. Yeah, the firewall sits here between the user and the server. The firewall receives the packet from the user and forwards the packet to the uh, server. Basically, user and server are kind of interacting or talking to each other. Although the firewall is kind of in between, and the firewall may at some point decide to pause this connection or may decide to terminate this connection or whatever. But user and server are interacting with each other and they're playing a role in that live interaction. This is what happens in packet filtering and stateful inspection firewalls. However, in application level gateway or application level proxy, that's not the case. There is no real connection between the outside host or server and, let's say, client or user. There is no such direct connection. The inside host or internal node is being connected to the uh, firewall, and that's it. Firewall receives the packet from this node, from this user, keeps them somewhere, and then makes a connection between the the firewall and the server. So here we are talking about two connections, two parallel connections. One connection between the user and the firewall. The second connection is between the firewall and the um, actual server. Basically, here is a type of man in the middle attack. The firewall plays the role of a man in the middle. And this user kind of assumes that it is talking to the server, and the server assumes that it is talking to this user while they are both talking to a third party. The user is talking to the firewall, the server is talking to the firewall. So it doesn't permit end-to-end TCP connection. This is a key point about application level gateway or application proxy firewalls. And here are the steps that kind of takes place. First, the user contact the gateway or the firewall using TCP/IP connection or TCP/IP application. The user is being authenticated. The user sends the authentication information, including username and password. And if the application level firewall accept that user, now the application layer firewall follows the user request and on its own. I mean that it goes and establishes a connection between itself and the user on behalf of the user. So after step 2, that the user is being authenticated, the gateway contacts the application on remote host and relays TCP/IP segment between the server and the user. And of course, later the firewall may examine the traffic after connection is being established, which means that because every packet that comes from the user or inside host, the firewall receives that, keeps that, and then forward it. So the firewall has the option to investigate or examine packets or even pattern between the packets and do whatever the firewall wants to do. The positive point is that uh, it's very easy in terms of the access policy, because you only need to uh, look at the applications which are allowable, and anything other than that is being rejected. And the shortcoming is, of course, clear, the extra delay or the processing time which is being imposed to the actual connection between the two kind of end side, between the internal user and external server. So that's the biggest kind of negative point about application level gateway. There is a kind of modification to application level gateway, which is called circuit level gateway, which is basically works the same thing. It sets up the TCP connection between itself and the TCP user. It sets kind of two TCP connections, and it doesn't let an end-to-end TCP between the user and server. and relays TCP segment or TCP packet from one connection to another, but it doesn't examine them. The very last thing that here I just mentioned for the application level gateway that I said it may examine the traffic in order to look at the traffic pattern and find some pattern in the traffic. It is not being kind of done in circuit level gateway. That's why they call it circuit level. It just makes the connection between the internal user and external server. And after making the connection, that's it. It kind of finishes and just relays the information. It doesn't look at the information after the connection, after the two connections are being kind of established. And the security function boils down only to just determining which connection should be established and which connection shouldn't. That's it. Once the connection is established, the circuit level gateway has nothing to do, and it just kind of keeps forwarding. And of course, this is good when the inside users are trusted, when we have some level of trust to the inside users. And if having that trust, while once the connection is established, that's it. We can just keep forwarding the user data to the remote server. And of course, it imposes lower overheads because we don't need to examine each packet or each segment of the traffic. Okay, the very last thing I'm gonna talk about in this lecture is host-based firewalls. Please use the term host-based, like whatever you see here as the attendance code for today's class. Host-based, H capital, B capital with a dash between them. Host-based firewalls are another type of firewalls that they're firewalls at the host or at the server side. You have a server. Of course, you are an organization. You may have some servers, and for protecting your servers, you may want to have some firewalls dedicated to your servers. And what they're basically software modules which are being kind of installed on the operating system, and they provide some kind of levels of protection to the host. And they, of course, work like conventional standalone firewalls, and they filter based on some access policies and so on. The advantage is filtering rules can be tailored based on the host environment because you are putting the firewall very close to the server. Here, kind of against this kind of figure that you see here, firewall is sitting somewhere between the host and the user. No, the host-based firewall is just sitting exactly on the same computer that the host is or the service is. So it's very close to the host. So the protection might be kind of maximized, and the protection can be, or the security rules can be tailored based on the host environment. And like I said, they provide additional layer of protection, which means that we shouldn't, for an organization, we shouldn't only go with host-based firewalls, because host-based firewalls, they're there for basically protecting the servers only. So if you have an organization with, let's say, 500 workstations or 500 users, a host-based firewall only protects your server. None of your kind of workstations or non-server users or non-server nodes is going to be protected with that. It brings an extra level of protection to the host computer that you have in your organization. Okay, I think that should be enough for today. We will continue with intrusion prevention systems in the next video. Thank you for attending this video lecture, and have a great rest of the day. Take care.